All right, so we are going to walk through 21. So 21 is one of the ones where they give us three numbers, right? So it's a percent yield. So again, first thing I recommend is identifying the actual. So what's our actual from this one? Okay.
37.9.
Good.
39.
Oh, yeah, I knew what you meant. 39.7 grams of the RB2O is our actual. Okay. So that means we're going to ignore that until the end of the problem. So the other two things they give us here should be reactants, which if we look, they are. So because we have two reactants, we're actually going to have to find the limiting reactant, run a BCA chart to find the theoretical product that should be produced. So I'm going to set this up. So far, RbO2 and 2RB2O. Okay, and then BCA. Okay. So first thing is we've got two reactants, correct? So we're going to need to turn reactants, tilt this a little here. We have to turn reactants into products. Sorry, reactants, we have to turn grams into moles, what I'm trying to say. Grams into moles. So we're going to do 82.4 grams of RB. And we're going to go grams of RB into moles of RB. RB is what, 85.5. Sorry, 85.5. So three significant figures. So this would come out to be 0.964 moles of RB. And we're going to turn the 11.6 grams of O2 into moles of O2. Remembering that for the grams, we're talking about O2, so oxygen 16 times 2, 32. We do the math. Three significant figures again gives us 0.363 moles of O2. Now, anybody remember where we put those? Yep. Good. In the before row. So we get on RB, we have 0.964. The oxygen row, we have 0.363. Okay. Anybody remember what we put under the RB2O? Okay, 0, yep. We put 0 because that's a product and we don't have any yet, right? Okay, now next step. Georgia, yep.
That's what I thought you were talking about.
No, I know. So we're going to divide by the coefficients to find our limiting reactant, right? A lot of people will forget this step. They'll just start comparing. You got to divide by the coefficients before you find the limiting reactant. So RB, in front of RB, there's a 4. In front of O2, there's a 1. So we get 363 still for this one. And for the RB, we get 0.241. All right, so what's our limiting reactant? Good. Now, they didn't really ask for that, but we need to identify in order to do the change row, right? So our change row is the smaller number, the one that showed us what the limiting reactant is, times the coefficient for each one. So 0.241 times 4 gives us the 0.964 times 1, 0.241 times 1, 0.241. 0.241 times 2 is 0.482. All right, everybody good with getting those? All right, so I'm gonna just move this up so we can see it more easily here. Okay, now after row, subtract reactants. This comes out to be 0.122. Add products. 0.482. Okay, now, anybody remember what we're trying to do? Yeah, percent yield, right? So we're trying to find the percent yield, which means we're trying to find the theoretical, the amount mathematically that it says we should get, right? Of RB2O. So what do we need to take to find the grams of RB2O? Good, right here. The 0.482 moles RB2O. We're going to turn that into grams. Okay. So RB2O in grams is 187. And we get 90.1 grams of RB2O. Okay. This is our theoretical, right? All right, so now we finally can do our percent yield, which is our actual, so the 39.7 grams of RB2O over the theoretical that we figured out, the 90.1 grams of RB2O times 100. Significant figures, we go with 3, so it's 44.1% or percent RB2O either way. All right.